Okay, so far we have discovered the point processing. Okay, we already cover the point processing, which is we already cover the basic transformation function, which is under this category. Okay, which is we have a linear transformation function, we have power law transformation function, we have a logarithmic transformation function, as well as piecewise linear transformation functions. In this video lecture, we will discuss about this part, which is histogram processing. Okay, in histogram processing, it consists of two approach, which is histogram equalization as well as histogram matching. However, in this course, we only cover histogram equalization. Okay, again, like I remind all of you, we'll still use a transformation function t there, okay, in this process. However, why it differentiate, what is the difference between histogram processing and the basic transformation function that we cover in the previous lecture, is that the transformation function that we have here, okay, it's generated, okay, instead of you have some equation, some fixed equation like the previous one. Okay, in the previous one, if you talk about the power law, you have a power law transformation function, and then you have negative transformation function, which is a very fixed transformation function. However, for histogram processing, okay, especially the one that we'll discuss later, which is histogram equalization, the transformation function is, we can consider as adaptive transformation function, because the transformation function will keep changing, which is depend on what kind, or what kind of condition that we receive from the input image. Okay, different input image will have different transformation function, which is the transformation function in histogram equalization is depend on the condition of the image. Okay, in histogram equalization, why I said it is a adaptive transformation function, because later we'll discuss about this histogram equalization process, where in order to generate or to produce a transformation function, later it actually is depend on what we call as a CDF, okay, which is or in other words, the CDF is represent a cumulative distribution function, and this cumulative distribution function is come from your PDF, okay, which is probability distribution function, and this probability distribution function is come from the image histogram. Okay, image histogram, and then this image histogram is generated from the image itself. Okay, this one is cumulative distribution function. Okay, while this one is probabilities distribution function. Okay, so this is the overall flow, meaning that from the image, later we will generate the image histogram, and then from the image histogram we will get the probability distribution function, and then from the probability distribution function we can obtain the cumulative distribution function, where that cumulative distribution function is actually is your transformation function for histogram equalization. Okay, so of course, in order for you to understand why this happened in histogram equalization, then you need to understand what is image histogram. Okay, this is the key of everything, meaning that any transformation function generated in histogram equalization process actually is depend on the image histogram, because image histogram is keep changing, which is depend on the image itself or the condition of image itself. Okay, now let's take a look about what is the definition or what is image histogram is all about. Okay, so what is image histogram? So image histogram of the histogram of an image show us the distribution of the gray level in the image. So means that so you can see that this is the example of image histogram. So in the horizontal axis there, or the x-axis there, represent the color of your image or the intensity level that you have in your image. If you talk about intensity level resolution of 8 bit per pixel, meaning that your gray level is from 0 to 255. Okay, so in other words, you can also write in this way, from 0, okay, from 0 to your L minus 1. Okay, so again, like I said, it's depend on the intensity level resolution. Maybe if the intensity level resolution which is not 8 bit per pixel, then you need to have your own gray level. Okay, you how many colors do you have in your image, and then the frequency here, okay, like what you have learned in your secondary school about the histogram. Then this one is the frequency, or in other words, how many pixels that how many pixels inside your image, which is represented by that color or that number. For example, if inside your image you have 10 pixel with 0 or with black color or with black, then we can say that the frequency is 10. Then at the 0 there you have one bar there until, okay, you present that as a 10. Okay, meaning that if you have one bar there at intensity or the gray level equal to 0, meaning that inside your image you have 10 pixel which is containing 0 value or black. Okay, that is histogram. So histogram, actually most of the time you will find this histogram is very useful, especially in segmentation. However, in this chapter, the histogram itself is also give a lot of benefit in determined or in generating your transformation function later. Okay, meaning that instead of using histogram for segmentation, okay, histogram can also determine how good your image in terms of whether your image is have the low contrast or high contrast. Okay, that is also you must take note, where histogram can determine how good the contrast of your image. Okay, the contrast of your image. Okay, now take a look of this example. So what can you comment on this image? Okay, what can you give a comment on this image? If you see this image we can consider subjectively, we can consider is a quite good. Why? Because you can see that the intensity range or the color range there. If I talk about colors there, it does not mean color image. Okay, if you focus on this grayscale image, you find out the pixels there. Okay, it's represented by various of color, or maybe a wide range of color, meaning that if this is the 8-bit image, 8-bit per pixel image, or the intensity level resolution is 8-bit per pixel, we can see that, oh, this image, okay, some pixels there is very wide, and then there's also very dark, and then you can see there's a variety of intensity gray levels there inside the image. So meaning that each color have been utilized inside this image from 0 to 255, okay, from black to white. So we can consider this image as a high contrast image, because the distribution of the color inside this image is I can consider as very well distributed from 0 to 255. So that's why we can say this is high contrast image. So if you plot the histogram of this image, you also can see this is the example of the histogram of this image. Okay, the histogram that is generated from this image. So you can see there, okay, this one is generated by Scilab. Okay, instead of using MATLAB, some people okay, prefer to use Scilab because that is open source software, so it is almost similar with the MATLAB. So the difference is just now you can see over here is a normalized version. Okay, you can just assume this is 0, this is 255. Okay, for Scilab they always normalize the value from 0 to 1 over there. So actually if you plot in the MATLAB, it will should be 0 to 255 if you talk about the intensity level resolution of 8-bit per pixels. So you can see that the histogram, the histogram or the frequency of or each the frequency of intensity levels there or degree levels there, and from 0 to 255, okay, each and every uh, you know each and every gray levels or intensity level have been occupied by most of the pixel inside the image. So that's why you can see there's okay, again, like I said, the y-axis represent the frequency or number of pixels. Okay, so you can see that almost all color have been occupied, meaning that the pixel inside this image, okay, consists all color. So that's why we can consider as this image as a high contrast image, because you have most of the color have been used in this image, okay, from 0 to 255. Okay, if you talk about the histogram, even the highest one is this one, means that the highest histogram here represent the highest pixel that consists of that color. Okay, I'm not sure what color is it because it have been normalized there from 0 to 1, so that's why we cannot identify that. Okay, how about this one? Okay, I already put the labels there. Okay, this one is not high contrast image, okay, because okay, this is we can consider as a low contrast image, but since the most of the colors there actually is belong to dark region or dark um, which is close to black, so or close to zero intensity levels, so that's why we call this condition as a low dark contrast image. So if you plot, okay, if you plot the histogram or the image histogram of this image, that is you can see that, okay, even here, okay, you have from 0 to 255, but the histogram only occupy at this level, okay, which is okay, just assume the centers there should be 1 to 8, okay, but you can see that it's only occupy this region which is half of 1 to 8. So meaning that since it's less than 1 to 8, or even might be less than 100, I think, so meaning that each and every pixel here, most of the pixels there occupy at the dark region, and because they are not utilize all the intensity level, or the pixel does not, the color inside this image does not consist of the wide range of intensity level from 0 to 255, only utilized from might be 0 to 100 only, which is very narrow over there. So that's why we can conclude that this image is a low contrast image, and not just a low contrast image since it's occupied at the dark region, so that's why we call it as a low dark contrast image. Okay, so this is first condition. Okay, this is second condition. Okay, the first one is high contrast, and then this is a low dark contrast image. How about this one, the third one? Okay, I already labeled the name of that condition, which is this image is also a low contrast image, but now is not however, this one, it's a little bit different from this one, even it's belong to the same category, which is a low contrast image, but this one, it's close to the most of the pixels there, or most of the color that occupy each and every pixels there is very bright or close to white. So that's why if you plot the histogram of this image, you will see this is the histogram of the image, where if you see over here, again, this one is 0 to 255, and if you put the half there, should be 1 to 8. Okay, you can see the histogram occupy only this part. okay, this region only, which is the bright region. Okay, this region. Okay, this is empty. Okay, this is empty. So if that is happen, so then this is called, this condition or this image is called a low bright contrast image. Okay, so you can see that, of course, the histogram is just for the purpose of double confirm. Even without, without generate the histogram, you can see that this is very high contrast and this is very low contrast, and because almost all image or almost all pixels there is very dark, so that's why you call as a low dark contrast image. But this one, because almost all pixels there is very bright, and that's why you call as a low bright contrast image. So in other words, image histogram is just for double confirm that things. So by having a histogram of each image there, then it's actually double confirm your answer there, or your classifications there, whether it's a high contrast, low contrast, and the low contrast, whether it's belong to a low contrast bright image or low contrast dark image there. Okay, so the one things I would like to highlight over here, don't confuse this one with the graph that represent the transformation function that you learned before, because the one that you learned before, okay, which is again this one, if you remember, we have R here, we have S here. So now this one is the intensity or the gray level of input image, okay, while this one is the intensity level of your output image. But histogram, okay, histogram, we are still using the R there, the intensity. Okay, this one is actually your R. Okay, is your R, the intensity level or the gray level of your input image. But this one is not your S. Okay, it's a frequency, or we can, or in other words, is also known as a numbers of pixels. Numbers of pixels. So number of pixels that belong to, let's say, 0, how many? 100. Number of pixels belong to, let's say, 1 to 8, how many? 50. So it's a frequency. Okay, how frequent that the element inside the matrix is 1 to 8. How frequent the number of 0 inside the matrix, or the image matrix that you have there is 100. So that is how you count. So how many frequent, of course, you can count the numbers of pixels. So that is why you can also known as the word that we use is it, you can use a frequency, you can also use the numbers of pixels. Okay, okay, how about this one? Okay, we have high contrast image, we have low dark contrast image, and then we have a low bright contrast image. How about this one? Okay, so this one actually we cannot, actually it's belong to low contrast image, but we cannot identify whether it's belong to whether it is close to dark or is it close to bright. So that's why, since it's 50-50, okay, the condition is very 50% should be, might be, it might be 50% going to dark and 50% going to the bright. So that's why we don't call it bright or dark, we just call it this one as a low contrast image. So if you plot the histogram, okay, you can see that the histogram is almost at the center there, from 0 to 255. So this one is 1 to 8. Okay, so we still call it a low contrast image because the pixel only, or the intensity level inside or the gray level inside this image, okay, is only occupy a certain range of intensity level, which is that, okay, meaning that is empty there and is empty there. So even actually you can utilize, okay, from 0 to 255, but this image is only occupy that range. It's a very small range, so that's why this image is also as known as a low contrast image, but it's not a bright, it's not dark. Okay, it's at the centers there, so that's why we only call this one as a low contrast image. Okay, how about this one? Of course, this one is the high contrast, because you can see that you have very dark there, 0, and then you have very bright there, which is 255. So we can, this one might be utilize all the colors, the available color for this type of image. This image is 8 bit per pixel, meaning that the available color is 256 from 0 to 255. This image occupy almost all colors. So if you plot the histogram, okay, this is the histogram. Okay, meaning that histogram is just to make or to double confirm whether that one is a high contrast or low contrast. If you talk about the high contrast, then the histogram should be utilize almost all gray level or intensity level from 0 to 255. Okay, but if you talk about the low contrast, it should be occupy a certain range, a very narrow range there. For example, this one, as well as this one.